Welcome to the ET302 video for the RC servo motor and windshield project using the Parallax stamp. Here I'm showing the Parallax RC servo motor that should have come in your parts kit. And this is what we call a hacked RC servo, and it should be the continuous rotation. What we do with a hacked one is we take out the feedback potentiometer and we make this a continuous rotation device. A standard servo would go from let's say 180 to 90 to minus 180, and this one is going to be continuous. Here we have our wiring. We're going to have a black, which is ground, red, which is power, and white is the signal. We're going to send a pulse signal with the white wire, and the power will be supplied by the other two. In our stamp P-Basic program, what we're going to do is we're going to send a pulse separated by 20 milliseconds. 20 milliseconds is 20/1000ths of a second. So this pulse width, this high pulse, is going to determine what direction and speed our motor goes. So the first thing we're going to do is we're going to check stop. And at stop, which is 1.5 milliseconds or 1500 microseconds, we're going to stop the motor. And there should be a little potentiometer, should be already adjusted, and it shouldn't do any rotations. It should just stop. So once we start going in the other direction, start going up, 2 milliseconds, we're going to go counterclockwise slow. And at 2.5, we're going to go clockwise fast. And at 3 milliseconds, we're going to go counterclockwise fast. So again, if we go back to stop, and we go to 1 millisecond, we're going to go clockwise slow. And 0.5, we're going to go clockwise fast. And 0 or almost 0, we're going to go clockwise fast. Now this clockwise and counterclockwise are based on which end of the motor you're looking at, so that's not fixed. On the last slide I showed a pretty much theoretical of how these servos, and that's pretty much what's printed. But here Parallax went through and actually measured how the servo is moving, and what they found was there is a very narrow window that we could change the speed. Once it's lower than 1400 milliseconds or 1.4 milliseconds, it's going to be at a certain speed. The same thing above maybe 1 millisecond, it is going to be the same speed. So there is not much variation in the speed, not between 1400 and looks like 1.6 milliseconds. And at 1.5 milliseconds, it's stopped. So we're just going to try to operate in this range here. And this was just recently discovered by Parallax. Here's our connection of our servo motor into our Board of Education driven by the stamp. So we have white, and you notice over here we have red and black. So we have black, red, white. White should be on top. 14 is the number of the servo, and that's the one our program will be calling out. And that's pretty much the only connection we have for our servo. There's two simple circuits we're going to add besides the servo motor. On the bottom, this is just going to be a simple display. It tells us when our circuit is activated. Here we're going to have a switch. And here we have a 1K ohm resistor tied to ground going into P1. This is called a pull down resistor. Okay, so this is going to send the microprocessor a low or a 0. Okay, and our program is going to ignore the 0. But when we take our 5-volt wire, and we're going to make this our switch, so when I take this wire and I touch it to here in between, we don't want to touch it here because that's a dead short. That's not good. So a pull down resistor, when I do this, it's going to give us a high, which is going to turn on our program. Okay, so this is a high. this is a pull down resistor where this resistor is large enough where this load on our pin isn't going to short it out, but it's going to give us a low indication. Here I'm showing our BOE with our windshield accessories. So here I've gone from pin 2 through a 470 to a LED with a flat spot. Then I've jumpered back to VSS. Here I have going from pin 1 a 10K. I say in the lab is a 1K, but I found a 10K and that'll work just fine. So here's our pull down resistor, and it's going to be going up to VSS. This blue wire here is our start switch wire, and once I touch it to this side of the resistor, okay, not this side because that's a short, this side we're going to put in a 1 and we're going to get the program to work. In order for the servo to rotate, we have to be in position 2. Position 1 for the microprocessor, position 2 is for the RC servo motor. Okay, let's try it. So I'm going to hit our start switch, and it's going to go 100 pulses, which looks like it's about 2.5, and that is finished. Okay, in order to make this look like a windshield wiper, I would modify these two numbers smaller to make it look like, I don't know, 25 to 90 degrees or something like that, and make them look like a windshield wiper. So just go ahead and lower that number, and that will reduce the rotation. If we hold the switch steady, it should continue to go back through this program and continuously wipe.